So as I was reviewing some of the chapter reflections and responses to the review questions asked for each of the assigned chapters in part 1 of the class, I noticed that most of the questions that students asked at the end of the review sheets, where it said, do you have any questions about these questions or your responses? Most of the questions that were asked related to some of the fundamental concepts that are sort of define what part 1 of the course is. And so I thought, since we're heading into your first assessment in the class, your first exam over part 1, that it was a good opportunity to kind of review with you some of those fundamental concepts of the class. So that's what we're going to do. And I'm going to use as an example throughout this kind of overall big picture review, the example of a math teacher. So suppose you had a math teacher who was interested in having his or her students learn a specific skill about division. So here it is. The math teacher wants students to be able to divide numbers that are greater than 100 by double-digit numbers with no remainder. And so the math teacher creates an assessment, and for the purpose of this big picture, we're gonna boil it down to 4 items. So 4 items designed to measure the learner's ability to perform that particular skill. So here's the directions. Students are asked to solve the following division problems. There will be no remainders. The first item, students have to divide 144 by 12. So it meets the criteria for the overall objective, and the item is written in equation form. So that's the first item. The second item is a little bit different because it asks the learners to translate the words of the numbers into numbers and then maybe or maybe not write them in some kind of a easier way to solve the problem. The third item is similar to the first one. And finally, the fourth item is the dreaded math word problem. I'll give you a minute to read through it. So hopefully, as you can see from this problem, the learners do have to apply that skill, the skill of dividing a number greater than 100 by a double-digit number. But there's also some other things in the problem that the learners have to deal with in order to recognize that is the division problem. And I believe that's probably one of the things that makes word problems a little more challenging for students in math, is that they have to be able to identify what the actual problem looks like in this case. So there you have 4 items designed to measure a specific and particular outcome. Now, collectively, we would call those items part of an assessment. And for the purposes of this class, the big picture, an assessment is a formal attempt to measure a learner's status with respect to variables of interest. So you're asked to define the term assessment, and that's how you do it. And you'll notice that it focuses on educational variables of interest. Common educational variables of interest are those outcomes associated with a particular subject area or content area. And they could be math skills or reading, language arts, social studies, science. But it could also be broader, sort of less defined skills related to things like critical thinking, communication, getting along with other students, collaboration. So those are also things that could be educational variables of interest, and certainly measurable in some way. And other educational variables of interest might relate to attitudes or dispositions about students regarding their own learning. Certainly, as a teacher, you're probably interested in having your students enjoy what it is you're helping them learn how to do. So attitudes like enjoyment would be a variable of interest, and if you're going to assess attitudes, you would do that in a formal way. And again, there are better ways than not to do that. But for the sake of this example, here we have our math teacher whose educational variable of interest in this case happens to be related to the learner's ability to solve a certain type of division problem. Now, before we look at what makes a good assessment, I want to just spend a moment summarizing what an assessment is versus what an evaluation is. Because on the surface, those two words are probably used interchangeably in the field of education, but they are different. They're different because assessment is measuring someone's status, and evaluation is making a value judgment about that status. So if, for example, somebody got all 4 of those division problems right, they answered them correctly, so they got 100%. That's an assessment. They got them all right. An evaluation would say, you would say, well, I'm giving them an A or even an A plus in their ability to perform division problems like that. So, and similarly, if somebody got 3 of the 4 questions right, but stumbled on the word problem, then you might, so in that case, you might say, well, I observed them scoring at 75% correct. But then you also might make a value judgment about that and say, well, they can perform those skills fairly well, and I would label them a C plus on that, 75%. So that would be an evaluation. This class isn't going to deal with evaluation at all. It's going to deal with just being able to measure well a learner's status with respect to those variables of interest. So what makes a good assessment then? That's the whole purpose of this class. This class is to help you primarily, first of all, identify good assessments, and then, perhaps more importantly, create good assessments. And what makes a good assessment is are 3 concepts or 3 constructs associated with assessment. The first is reliability, then validity, and fairness or absence of bias. So a good assessment, you can collect evidence, or you can estimate that an assessment is a reliable assessment. You can collect evidence that it's valid, and you can identify that it's fair. Those are the 3 fundamental characteristics of effective assessments. And so we're going to kind of look at all 3 of those areas individually, the way they're presented in the course text. So the first area is reliability. And in reliability, even though there's a lot of information in the course text about reliability, we're going to focus on 3 specific ways in which you might estimate the reliability of an assessment instrument. And again, I'll go back to that math example in just a moment. So the first area of estimating, I should say, reliability is called the stability or test-retest. And that's simply whether or not, if you administer an assessment at one time to learners, and then you administer it again at a different time, the learners should generally perform roughly the same on it, regardless of when it's being administered. And something that's a little bit unclear, but I hope to clear it up, is that administering an assessment at different times doesn't necessarily mean that you're administering the same assessment to the exact same group of learners. It could be to a subpopulation of your overall learners. So let's pretend for a minute that you're a math teacher and you have different class periods. If you administer an assessment to the very first class period, if you wanted to estimate a high reliability, you would assume that if you administer that class or that assessment to a 4th or a 5th period class, that overall the learners would perform roughly the same on it. Now, of course, there are reasons why they wouldn't if you observed it, and some of that could very well be related to the assessment items themselves not being very reliable. For example, let's say that by 4th period you're giving students examples that never came up in 1st period, and the assessment items connect directly to those examples. In that case, you're putting your first or second period students at a disadvantage with that collectively with that assessment, because in essence you might have even given away the answer, or however you want to frame that. So you want to make sure that you have a reliable assessment that functions the same for the same population of learners, whether it's a subpopulation or not, the same population no matter when you administer it. So that's stability. The second common way to estimate reliability is alternate form reliability. And that's where you take a collection of items designed to measure a particular skill, like the 4 assessment items that for the math teacher on division, and if you had different versions of that, so you had the same types of problems but different numbers in those equations, or different subjects or different amounts in the word problem, if it's a reliable assessment, then your subpopulations of learners should perform roughly the same on one version or the other. And by the way, one of the ways that you determine how well the two instruments, two alternate forms would function, is by calculating a coefficient that is a math term that refers to a measured amount of something. And in this case, you would be measuring, you would correlate the performance on one version versus another. And that's correlation is a mathematical sort of test that you conduct, and you see how well a group of students do on one and how they do on the other. And a high correlation would be a good estimate that the different alternate versions are reliable. Similarly, the third way that you can estimate reliability is through internal consistency. And the way you determine internal consistency is you look at how well do students perform on one item versus how well they perform on all the other items. If it's an internally consistent, reliable assessment, then the learners who do well on one will do well on all of them, and the learners who don't do well on one won't do well on any of them. So if you analyzed the performance of students on that 4-item division assessment, and it turns out that the students did really well in general on all 3, but many missed the word problem, and yet they did really well on the others, then that would be a low estimate of reliability. Reliability would be kind of low on that particular item. And again, you could say, yeah, well, it's just a challenging more item. It's asking them to apply other things that they learned. Yeah, it is, which makes it not a very reliable way to measure that one specific skill, because you're having to depend on them being able to perform other skills as well. So that's internal consistency, and that's a really common type of way that teachers would estimate the reliability of a particular set of items on an assessment. And in fact, you're going to have an assessment in this class soon, and one calculation that is done automatically by the assessment system is to determine internal consistency. So I'll get a number that says, here's how this is the internal consistency, not only for the assessment overall, but also for each item in the assessment. That is, how well did people who perform well on this item, how well did they do on all the other items, and specifically. So that's a way to estimate reliability. So the second construct related to whether an assessment is good or not is whether or not it's valid. Now, validity is a really important idea, because validity addresses whether or not the items in an assessment actually measure what it is you want it to measure. And like reliability, I'm focusing on 3 characteristics, 3 ways to collect evidence that an assessment might be valid. The first is called content validity. Now with content validity, you're just looking at whether or not the content itself within your assessment items actually is accurate. And so content validity it examines are the words and ideas that you use to communicate the items accurate. One of the most common ways to determine content validity or collect evidence that you have it is by having an expert look at the items and say, yeah, this is accurate. That expert might be you, because you can be an expert in the subject area that you're teaching, certainly. The expert could also be an external source. You can compare what it is you're writing to some body of knowledge that you trust, that you trust is an accurate reference for that. Also, content validity also looks at whether or not a collection of items adequately addresses the scope of everything that you want to measure. For example, if you've got a collection of division-related skills for a math class and you're giving a large assessment, you would want to be able to identify that the number and breadth of items covered all the skills that you wanted it to. So that's content validity, and usually that's the evidence of that validity comes from kind of inside your own brain, you know. So the second primary area where you can collect evidence of validity is an area that we call construct validity. And construct validity is how well assessment items measure a particular construct. And a construct is an idea or a theory that is subjective. And so the only way that you know that you have that is by measuring it by way of some examples. For example, a common construct in education is the construct of critical thinking. You want students to learn critical thinking skills in their experiences in the classroom. But how do you know that somebody can think critically? The only way that you can tell is by developing some assessment items that do a good job of measuring what you think is critical thinking. So, and again, sometimes the best way to do that is to look to external resources, experts who have identified these constructs and then figured out ways to measure it using the third type of evidence for validity called criterion validity. And criterion validity is where you correlate performance on some items with performance on an external criterion that reflects that. For example, there might be an assessment out there, a separate assessment on critical thinking for adolescents. And that external assessment you might use. You would administer it to your students, say at the beginning of a semester, and then they go through your course, and at the end of the semester, you would predict that if you focused on critical thinking skills, and you had items that measured critical thinking skills throughout the year, that your students' performance on your critical thinking measures would correlate highly with some external measure. So that's criterion. Another example of criterion validity would be you focus some of your instruction on having students perform well on an external assessment like the Virginia Standards of Learning. And so you would predict, if you have items with high criterion validity in your class, that means that how well they do on the items you create in your assessments correlate highly with how well they do on the Virginia SOLs. So there's a really tight relationship usually between construct validity and criterion validity. So hopefully that explanation clears things up a little bit. I hope that it does. Another good example of construct validity would be going back to this idea of measuring attitudes. If you wanted to measure positive attitudes towards math instruction, for example, you might develop a set of items that ask the students to respond collectively about how they feel about math, and in order to measure the construct of enjoyment in math, you would collect some evidence that how well they perform or how well they answer certain of those questions would correlate highly with a broad question of, on a scale of 1 to 10, how well do you enjoy math? So you might have a question, for example, that says, I choose to do math homework, extra problems for math homework that aren't assigned. And you might predict that responding to a question like that with, yes, I like to do extra just math problems in general, that would correlate highly with their response to another item in the survey that says, I enjoy the subject of math. So again, that would be an example of doing an internal consistency analysis that would help define the construct of math enjoyment in your class. Sounds a little confusing, but you just, for this particular part of the class, you just have to understand, generally speaking, what constructs are and how important it is to be able to collect evidence that you're actually measuring the construct that you want to measure, and that would be construct validity. Now finally, the third area of looking at whether or not an assessment is good or not is whether or not it's unbiased, whether or not it's fair. And I'm going to go back, I'm going to summarize this whole thing by going back to our math example for a moment. I would say that if I was analyzing those 4 items, I would look at that word problem, item number 4 specifically, and I would say this item is, first of all, it's biased against the students in class who aren't as good of readers. So it's definitely biased against that. And it might be biased against people with certain language difficulties that are not related to reading. It could also be biased against people who may not, there's some implicit understanding of certain steps that would need to be taken in order to actually perform the division that you're trying to measure. And maybe some students in your class never learned those particular steps. For example, in that example, you assume that everybody has a good understanding of what the different coins are and what their values are. And if you've never measured that or checked for that level of understanding among your students, then this item would be biased against students who just don't even know that the value of a quarter, for example. So also, students, in order to answer it correctly, have to disregard the 7 cents. There's 57 cents. And they have to know that, well, the 7 cents don't matter because you can't get a quarter out of that. That would likely be a nickel and 2 pennies or 7 pennies. And again, that's an understanding of something that's different than division. So in that case, that item is not free from bias. And I would say that you're probably going to have trouble with students performing well on that because, frankly, you're measuring something you never taught them. So that's it. There are 3 primary categories of ways that you can determine if an assessment is good. That's what part 1 of this class is all about, kind of the big picture stuff. In the subsequent parts of this class, you're going to look at how you might actually develop assessment items that maximize the probability that you will create reliable assessments, that you will create valid assessments, and you will create items that are free from bias.